All right. So welcome back, everyone. Hope you had a nice weekend. I wanted to start by finishing up going through the pandas library and telling you a little bit about how to index out different columns and rows of data frames. And then I thought we could play around with some data visualization libraries after that and start digging into some real data sets. So let me paste in the link to my slide so that you can copy and paste code. Here we go. And then I've got my notebook here with just Kareem's friend. You can pull up a seat if you want. Okay, so all I'm doing here is importing the pandas library, pasting in the code from that slide right here, and then I'm turning it into a data frame with this code right here. Okay, so if we run all that, then we're going to get a data frame that we saw last class. So it's got different states on are the indices, and then the data frame has two columns. One is population, which stores the population for each state in number of people. And then the second column stores the area of each state in square miles. Okay, so let's go through a few useful things. So can anyone tell me if I wanted to pull out just the area column, how would I do that?
States and then area.
Yeah. And does anyone know what type of object this is? Does anyone remember? It's a
data frame.
Close. It's the other main data type that pandas introduces. Yeah, it's a series object. Because, yeah, so it's like a set of, it's like a vector with labels for each element. Interestingly, we could get a data frame if we probe a set of these columns. Oh, what did I do here? Sorry. Didn't mean to get. So you can pull out multiple columns if you pass in a list of columns as opposed to just a single string for one column name. And this is an example of how you could rearrange the columns. Allison, you're appearing twice here. It's the same you, it looks like. Okay.
Yeah, sorry.
Oh man. If you do that too much.
The screen, because it's just me.
Got it.
Mute here, hold on. Sorry, I'm projecting it on the screen and then I'm watching it also on my computer, but I can turn when I'm off because it's a little confusing.
Got it. Kareem, yes.
It's just me today.
Okay.
From the given link, how do we direct ourselves to the pandas playground IP Y and B? Because I can only find...
This is just a notebook I made, but I'm happy to share it with you.
Okay.
There we go. I'll paste it into the chat. All right. So, okay, great. So we can get out a single column by using, as Fan Marie said, just square bracket notation. And if we want just the area, that gives us a series with just the area. We can pass in a list of multiple columns, and then we get a data frame of just those columns. So if we had a third column, so if we made like a density column, so, population divided by area. Now states has 3 columns, but we could, index out a subset of those columns and, reorder the columns however we want. And now we only have, a portion of the data frame. What if we wanted to get out, oh yeah, Kareem. Or did you have your hand raised from before? Okay. What if we wanted to get out just the rows for California and New York? How would we do that? Or we could start with just California. How could we get out California? Like, will this work? What do you think? Who says it'll work? It will not work. So we'll get an error. Okay. So how could I fix this to get out just the row for California? Does anyone remember?
There was some prefix to states, I think.
Yeah. Well, so it's called loc for location. And that'll give me a series object. So we could check that. Corresponding to the row of this data frame. And the series object has 3 labeled elements because there are 3 columns in the data frame. 1 for population, 1 for area, and 1 for density, all for the state of California. I could also get out multiple locations. Like if I wanted California and New York, then I get out a data frame. So I can check that data frame containing all the columns of this data set, but just the rows for California and New York. And then I could further subset out just a subset of the columns by saying, like, if I just want the population and density, then I can do that too. And what's happening here is this is a data frame, and now I can subsample out some columns of that data frame. The other way to do this is I can use just in loc, it lets me index the rows and columns. So I think this will work also. No, just kidding. Let's see if this works. I doubt it. Nope, just kidding. Yeah, you have to do it the first way I said. Kareem, yes.
So when you call .loc, does that simply extract things from the original data frame, and then it doesn't create a copy or anything, right? So if you were to call states right now, you'd get the original one with all of them, right?
Well, let's yeah, that's true. But also, what if I reassign the values to 0? Okay. Oh, sorry. Yeah. So you can use this to reassign values. I could also say, let's see, area and density. And let's call this subset. So now this is like a little window there. We could say, so let's set the value for all the columns of California to 1. Then we could ask, did that change the original state's data frame? And it does not. Yeah, so this is a little bit different from NumPy. You're getting it's not actually true of all pandas functions. Sometimes you get what's called a view or a window, where for some pandas functions, it does not recopy the data, but in other circumstances it does. It's somewhat hard to keep track of when it does versus doesn't. So the best thing to do is just try, little toy examples. If you want to explicitly copy a data frame, then you can use .copy, I believe. It's totally fine with that. Okay. You've got 2 Allisons and 2 Emilys now. All right. Weird, enrollment just doubled. Okay. Great, so we have loc and just column indexing. Let's see. Sorry, you've got a jet engine going in the background there. I don't know if you can all hear that. Okay. Let's see. Another useful function is called iloc. So if we want just the 3rd row of this data frame, we can put a little I in front of it. And even if we don't know the identity of the 3rd index, we can get it out using iloc of 2, which, because Python is 0 indexed, that would be the 3rd row. So that corresponds to this row of the table. Or I could get like the 2nd to the 5th row or something like that. Or sorry, 3rd to the 5th row, etc. And the reason it goes only to the 5th is because in NumPy and Pandas, the start point is inclusive and the end point is exclusive. So it goes 1 before the position 5, which is the 6th entry. So we're getting out the last 3 rows. Yes, Allison.
Wouldn't it be, wait, you said the start point is inclusive and the ending point is exclusive. So why would it not then just be
That's right.
from 2 to 4?
So if we did 2 to 4, then
No, I mean, like, why is
return
5 not actually equal 2 to 4? Because you said the last point's exclusive, so 5 shouldn't be included. And you said the first point is.
Well, remember, position 5 is the 6th row because the first row starts on 0.
Okay.
Yeah, so if we just went to 4,
okay.
then we would
That
get
makes more
rows
sense. Okay.
2 and 3. So that's the 3rd and the 4th rows, etc.
Okay.
We could also do this. So 10, there aren't 10 rows in the table. If you kind of overshoot, then it'll just stop at the end. If you just leave off the end point, it'll just go to the end. And if you go to -1, it'll go to like 1 before the end, or if you go to -2, it'll go 2 before the end, etc.
Okay, thanks.
You can also both index the rows and the columns using iloc. So this works differently from loc, which is why I am sometimes confused by this, but if you do, like, let's take the third row to the bottom, starting from the third row, going all the way to the bottom, and then starting from the second column all the way to the right. We can do both of those operations in the same step, kind of like we're indexing a NumPy array. That only works with iloc. Yeah. How are you all feeling about those? Does that make sense? Okay. So next I want to play around with another data set. I'm going to paste in the URL to the chat so that you can copy it. Let's load it in. So the thing stored at this URL, like if you paste it into your browser, it's a CSV file. And it's a bunch of like stats about cars. So we can read it in using pandas.read CSV and then the URL. And then you can get a little summary of what's in it by saying cars, and head prints out the first 5 rows, and then tail prints out the last 5 rows. And then if you want to print out the first 10 rows, you can just pass in, a number to 10 specifically to head. But it gives you like a little summary of what that data set looks like. Okay, so this is going to be like a bunch of cars, and we can see, yes, Allison.
2 quick questions. The first is it preferable to use like a CSV format for our data versus something else?
The easiest formats to work with are any formats that Pandas supports. There are quite a few of them. There's something called pickle files, which are like a Python compressed binary format. You can like read text directly from the clipboard. That's not good for this course, but you can read like, let's see, Excel files, JSON files, HTML files, XML, LaTeX tables, HDF5 tables, Feather, Parquet, ORC, SAS or SAS, SPSS, SQL, BigQuery, or Stata files.
So what will we be
amongst
mostly
others.
using in this class? Or like, what do you recommend?
Well, in this class, you'll be downloading data sets from whatever format someone else puts the data into. So
Okay.
if someone else saves their data set as a Excel spreadsheet, then you'll use an Excel spreadsheet. If the data are saved as a CSV file, that's what you'll use. So you're not going to be collecting data in this class. You'll be downloading it from existing sources. And basically, every or nearly every data format that you'll encounter is covered by pandas. And if it's not, there's a very good chance that someone else has written a parser to convert that weird data format into a pandas data frame.
So if we have like the choice, one of the other, is there one that's, I don't know, generally easier to work with or higher quality? It really doesn't matter.
It really doesn't matter. The CSV files are the easiest to make because it's just like the entry is separated by commas. It kind of depends on the data set also. So if you had a data set of like transcripts from movies, which could be a fun thing to look at. Let's say you have like a huge spreadsheet with 1 row per movie, And then one column is like the movie name. And then the second column is the entire transcript of the movie, which could be like several megabytes. And then you have, let's say, 1,000 movies. That would be an interesting data set, but the transcript is probably going to have commas in it. And CSV files are like the columns are separated by commas. So a CSV file wouldn't be a good format for that particular data set because you wouldn't be able to distinguish between like commas that you actually wanted in the transcript or commas that denote separate columns. So an Excel spreadsheet would let you kind of distinguish those. Similarly, like you can have, I mean, you can find anything to be your delimiter, but like if you use tabs for to separate the columns, you could also have tabs in your data set, or pick any character. So Excel is a little bit more robust. JSON files are also pretty robust. There's a lot of options. Yeah. I wouldn't say one is best. I think CSV is like the lightest format. There's the least, like the files are small because it's just like a text file. But it's not better or worse. And reading this in, if this was an Excel spreadsheet, you just replace this with read Excel. So it's not harder to use. Okay. Okay, so this particular data set, you'll notice like the first row of this data set has the column names. And that's a common feature of many data sets. And Pandas assumes that the first row of a CSV file that you read in is going to have the column names. There are all kinds of options. If you read the help file for read CSV, like one of the options is header, and you can like specify that there is no header for this table, or you can specify a particular column as like what should be used as the index. So like, by default, everything is indexed by the integer 0 through number of rows -1, but I could set like the name as the index, and then each car, like the rows would now be indexable by the car names, etc. There are lots of options here. It's not worth going through all of them, but some might be useful for digging into, and there are like tutorials and extensive documentation if you ever find the need to look into all that stuff. In general, just the default options tend to work best. And the way to make sure it's been read in correctly is by like printing out different parts of the data set and just manually looking at them. Now, if we want to kind of understand what's going on, a useful function for kind of getting a quick summary is called describe. Describe prints out a kind of report of what's happening in, I apologize for the noise, what's happening in different columns of the data frame. So you can get like the number of entries, that's the count, the mean value, standard deviation, minimum, maximum, and each quartile, etc. So 50% would be like the median. And this is itself a data frame. So, we could treat that like any other data frame if that were of interest. So we can index this, like if I want, just the count and mean and standard deviation. Totally fine. Let's see, what other useful things do I want to say here? Oh, yes. There are tons and tons of like data wrangling functions. So if you've got like missing data, fill NA, which fills all the NaN values, the kind of missing values with a particular value, or F fill is for forward fill and B fill is for backward fill. So if you've got like, let's say a history of stock prices and the company was formed on some date, and you want to then like anything before that date is going to be NaNs, like missing data. But for the purposes of some analysis, you could backfill all of the dates of that stock with the earliest price that you have. Or if some company goes out of business and drops off the stock market, you can forward fill with that value. Yes, Alex.
Does that mean that if you have single instances sprinkled throughout the data of missing values, they will take either the data point before or after whenever that shows up? Or is it just for like huge?
Well, so for forward fill, you take the previous value and move forward. And for backward fill, you get the most recent value and move backwards, or the next most recent value. And it could be, it's like one or more values get filled in.
Okay.
And then fill NA just fills all the NaNs with the same thing.
Sweet.
Group
Oh,
by, sorry,
Sorry.
yes.
What do you mean by the same thing? That would be the main, or?
Well, let's say you wanted to, I don't think there are any NaNs in this particular data set, but you know, if we wanted to fill all the NaN values with 3, sorry. Then if there were any missing values, we could specify what we wanted them to be filled in with. We could also say, let's fill it with the string missing data. That'd be fine too. There is no missing data, so it doesn't modify this particular data frame. But we could also like forward fill. Or backwards fill, etc.
Not that we have.
Oh, go ahead, sorry.
How would we delete data in a data frame? Or like replace it with an AND?
Well, that would be 2 separate things. So if you want to set the value, let's say we wanted to like set the origin of, I don't know, Buick Skylark 320. Let's see, cars.iloc of, so yeah, oops. And then let's say the weight. Let's say, you know, we measured that wrong. So let's, oops.
Would iLoc have to be?
Oh, I'm sorry. It should just be loc. Sorry, iLoc takes in integers. So yeah, so let's see what this looks like now. That did not work.
Is it not indexed by name yet? And
oh, you're totally right. Yes. Yep, that's right. Yeah. So let's
here.
Yeah, so it's actually cars of actually the index is 1. And then thank you. what do we say, weight? Yeah, there we go. There we go. Okay. So now it works. Okay. And if we could also drop a column. So I believe it's just drop. So you could drop the first column. Or sorry, drop a row. You can also drop a column. Let's say we want to drop the miles per gallon column. Yeah, you can say the column name, or you can say a list of columns. And then this will actually give an error. But so to drop a column, you have to say axis equals 1. Because by default, it'll search for an index. But you know, and that's the 0th axis. Another kind of interesting thing, the drop function returns a new data frame that is a copy of the old data frame with the modifications you gave. But the original data frame is unmodified. So those columns columns and rows are still in the original data frame. If you do want to modify the original data frame, you have to use the in place flag. Oops. I guess it has no parentheses or no underscore. And now those are missing from, you know, now this row is missing from the original data frame. Of course, we don't want it to be missing, so. Let's see what, another useful thing is group by. So let's say we want to like get a summary of like cars by year. Yes, Allison.
Quick question. So let's say like you make the new, you use the in place and then you decide, oh, actually, like I don't want to make a change anymore. Do you just delete that line of code, or is there something else you need to do to like turn it back to how it was?
If you use in place, then the data, you have to reload the data set.
Wait, what do you mean?
So like you'd have to reinitialize that variable with the data frame. You can't undo a deletion. So
okay.
when I run this cell, it like downloads the data set again from this URL. And now I load it in and it's fine.
Wait, so sorry, can you show what you mean one more time? Like, are you just running it again, or you're just?
Yeah, I'm running it again. So I'm clicking and that reloads the data set.
Okay.
And now it's the original unmodified version.
And then say you decide, oh, wait, actually, I was happy with how it was before, and I want to go back to the deletion part, then.
Oh, then you have to, you could say cars.drop. Let's say we want to drop the first row. Well, this will just return a data frame. So the original data frame will not be modified.
Okay.
But if we say in place equals true, now the original data frame will be modified. And also it doesn't return anything anymore. So, but now the first row is missing, or, you know, the row with an index of 1 is missing.
Okay, thanks.
Would that be possible to drop a column instead of a row?
Yep. So which column do you want to drop?
Acceleration.
Okay. Yeah, so this will give an error because it's looking down the rows. But if we say axis equals 1, this will return a new data frame that's the same as cars, but without that dropped column. And then if we want to affect the original data frame, we say in place equals true. And that won't return anything. But now if we print out cars, it now has a missing row index 1 and a missing acceleration column. There are also tons of really useful features for like grouping and summarizing data. One of my favorites is called group by. Yes, Kareem.
So does the in place essentially just do what we're asking it to do, but to the main data frame?
Exactly. Yeah. So by default, Pandas copies just keeps making copies of the data set, which is slow and inefficient. But so the purpose of NumPy, the reason it doesn't make copies is NumPy is made to like work quickly with big data sets and lots of numbers. And so it is all about memory efficiency. All the like fancy linear algebra functions are implemented super efficiently in C and then wrapped with Python code. So, I mean, we don't have to worry about it as the user, but everything's super efficient. Pandas is all about like correct modification and manipulation of data. So it sacrifices speed and efficiency and memory, including memory use, for the like kind of the ability to control very precisely exactly what happens with data, and like the defaults are all set up so that you're not to like minimize the chances of you getting the like wrong conclusions from your data set. Like if you you don't accidentally modify your original data set when you slice out some of the rows, or if you merge two data sets, the labels have to match in order for that merge to work. And Pandas has all the rows and columns labeled, so it knows how to merge things, etc. Or if you have like two time series, one recorded, a year and a half ago to a half a year ago, and the other recorded a year ago to now, those are both like a year long, but the time points will match up when you merge them as long as they're labeled with Pandas. So it's like really good at dealing with kind of labels and, matching things up. But the cost is that under the hood, there's a lot of copying that happens. So if you have a big data set, then there's a decent chance it'll just get copied a gazillion times with Pandas. And so that can start to be inefficient and whatnot. When do you need to import Pandas, NumPy, or both? Pandas is its own library. If you want to use any NumPy function, you have to separately import NumPy. Oh, you have to actually, oh, gosh. My keyboard is jumping away as I'm typing. Okay. Yeah, so if you don't explicitly import NumPy, then it could be the case that, let's see. Yeah, I don't think. Yeah, so like occasionally there are like hacky ways to get at libraries that are included in another library, but there's no like clean way to do it. We could maybe dig around and find the like version of NumPy that gets imported by Pandas, but we also don't need to.
As a rule of thumb, then, is it better to just always import both, or is there any negative to just importing both?
I almost always import both. Yeah. Good question. Okay. So what I thought we could do next is just to like get more practice playing around with Pandas, and also getting to dig in a little bit to some data visualization libraries, is I thought we could play around with some real data sets and you know, make some pictures. Okay, so we'll get to use pandas and some visualization libraries. So let's see, so I've put together 2 demos here. You can start with this one. Oops. Okay, so let me paste this into the chat. Okay, so you want to click that link and then click the Open in Colab button. Yes, Eliza.
Can I ask a quick question on the fill function? Because I didn't understand the difference between fill NA and fill ffill. Because in that case, are we going to specify the number of empty spaces to fill? Otherwise, it would be the same, right?
No, so fill NA, like, so let's say you have a bunch of nans right at in the first rows of your, like the first 5 rows of your data set. Fill NA will replace all of those nans, or not a number, like missing data, with the value you specify. Let's say you want to fill in zeros instead of nans. So that'll work just fine. But if you forward fill, then data, there's nothing before those first rows. And so those first rows just won't get changed. So they'll stay as nans with forward fill. With a backward fill, if the 6th row has data, then anything in the first 5 rows that's missing is going to get filled in with the entries from the 6th row. So backward fill will remove nans in that case. But if there's missing data right at the end of your table, a forward fill will catch it, or a fill NA will catch it, but a backwards fill will not catch it.
Okay, so it will be substituted with the newest value then?
Yeah, so a forward fill gets substituted with, like a nan will get substituted with the most recent value prior to that point, if it exists. Otherwise, it'll stay a nan. And a backward fill will get substituted with the most recent future value, like the closest into the future value, if it exists. Otherwise, it will stay a nan. And then a fill NA will just replace everything. It doesn't pay attention to labels or order or anything like that. In general, there's also like drop NA, which drops all your columns or rows if they have nans. So that's sometimes useful. Like you don't always want to replace missing data with a specific value because that makes an assumption. So if you've got like housing prices and one house price is missing, you don't necessarily want to fill in that price with a 0 because like what are the chances that a house price actually is actually 0, like pretty low. So you might just want to drop that row of the table. Okay. Does everyone have this notebook loaded up? Okay, it's not authored by Google, but that's okay. I will certify that it is safe to run. Okay, so we're going to install the Davos library, which is going to give us access to the smuggle keyword. And then we're going to install a bunch of the second cell with code in it is going to install a bunch of kind of libraries that are going to be useful for playing around with this data set. Okay. And then we're going to play around with 3 kind of sample data sets. So I'll just describe them as the libraries are installing. Yes, Allison.
Sorry, this may have seemed obvious to everyone else, but what exactly do we need to run in order to install the libraries?
Just press Shift and Enter and that'll run the first cell, and then keep pressing Shift and Enter until you get to this cell.
Until,
So you-
so until low data sets. So there's only 2 of them are running.
Yep, just 2 cells.
Okay, and then what do we do after that?
Now, to load the data sets, you run the load data sets cell.
So then we just
And
run,
then-
keep running everything on here?
Yep, just keep running everything. Yep.
Okay,
So what these data sets are, these are in this repository called OpenML for Open Machine Learning. And this is like a huge kind of store of many different data sets. And these are just 3 like popular ones. The California data set is about like housing or house properties and pricing in California. The digits data set is a data set of images of handwritten digits. And the wine data set is properties of different wines, like the drink. Okay, and we'll do some, oops, what did I do here? Okay, so run those cells, and we can like look to see what these data sets are. So, okay, so for the California data set, each house is going to have an ID and then a bunch of properties. There are lots of them. Like how many fireplaces, how many cars in the garage, does it have a screened-in porch? Sorry for the crazy kids running around. Oh my, okay. Yeah, it's sale condition. I don't know what abnormal means for sale condition, but I guess it can either be normal or abnormal. And then the sale price, I would assume in US dollars. And then it's got like year sold. Okay, so there are lots of prices. We could also ask like, what's the size of this data set? Using shape. So we've got 1,460 houses, each with 80 properties or 80 features or attributes. Okay. Digits is a bunch of pictures of digits, but the way the data set is formatted is the index tells us what the actual number is. Sorry. And the oh wow. One sec. Okay. Sorry about that. I have no idea what I was saying. Okay, each row is for a different handwritten digit, and these are images that are 8 by 8, I believe. Yes, 8 by 8 grayscale images, and that have been reshaped into vectors of length 64. So each row gets like concatenated next to each other. And then the values tell us like the pixel intensities at that position. So like 0 through 7 would be the first row of some image, etc. Okay. And then wine, I forget, yes, Allison.
sorry, I'm just a little confused what the digits is referring to, like what this is even about.
Yeah, we'll do some examples I think it'll make it clearer.
Okay.
Think of like each row is like a picture of a digit, of a handwritten digit. So if you like wrote the number 0 on a piece of paper, then took a picture of it and then reduced the resolution to an 8 by 8, so super low res photograph, that's
Okay.
like what the first row would be. And then there are like lots and lots of these entries. So this data set is used for lots of things, but one is like if you wanted to train a computer to recognize handwriting.
Oh, that makes, I was like, what is this data set used for? That makes a lot more sense. Okay.
Yeah. And then wine, there's some property of wines that's being labeled, and that's what the index is. I forget what that label is off the top of my head. And then the properties are like different properties of wine. So you can just think of them as abstract features, unless you know about wines, in which case some of these might have meaning for you. But these are all just numbers. So each row is a different wine, and each wine has different properties. Okay. So one way that I like to start getting insights into a data set is using the HyperTools package. And one thing we can do, so you can think of each digit in the digits data set as like a 64-dimensional thing. So each dimension is the value of like the intensity value at some pixel. So if the images just had 3 pixels in them, let's say the first 3 columns, then that would give us a 3D plot. Let's say like 0 was the x-axis, 1 was the y-axis, 2 was the z-axis. And you can imagine how like bright the first pixel is, gives us the position along the x-axis, and so on. Then the first 3 columns would be like 3D coordinates. But this is there are 64 columns, so each image is like a 64-dimensional coordinate. Now that's hard to picture, but what the HyperTools package does is it lets us pick, it creates an image of a high-dimensional thing, in this case, a 64-dimensional thing, and it creates the 3D image that most closely approximates it, so that our human, our puny human brains and visual systems can actually make sense of what's happening. So each dot here is a different color, or sorry, is a different observation or image. Each color corresponds to a different digit label. And then the positions of these dots tell us about the different images. So dots that are nearby correspond to images that like are similar. In other words, they have similar intensities at similar pixels. And so one thing you can see just by looking at this is dots that are similarly colored clustered together. What that means is that image, sorry for the crying now, being 4 is tough. Let's see, images that look similar tend to correspond to the same digit. Then we can actually dig into this data set. Let's plot some examples of like what these digits look like. So, okay, so, if you want to apply this to your own data set, here's the command. So that's, okay. So we can take each row of that data frame, which is a 64-dimensional vector, reshape it using NumPy reshape, which we learned about, into an 8x8 2D matrix. And then we're going to make a heat map of that matrix with a grayscale, using grayscale. And then we're going to show what those heat maps look like. And then that'll let us visualize what the images in that data set are. That lets us kind of get at, okay, what do these examples actually look like? And then we'll plot the, just for convenience, we can plot the actual labels of those digits, of those images to see, do these make sense? Do these not make sense? So, this function or this code just prints out the first 10 observations from the digits data set along with the labels and the images. So the first digit is a 0. We can see it kind of looks 0-like. The second digit is a 1. You can see it kind of looks 1-like. This is a 2. You can see it's kind of like a low res too. 3, 4, 5, 6, 7, and 8, and a 9. So the first 10 examples happen to be in order, but they're not all in order. There are many, many, yeah, so there are, almost 1,800 images in there, and they're all the digits 0 through 9. So there are repeats. Okay. And these heat maps are made using the Seaborn library. And the syntax is you just pass in SNS is how we call how we've named Seaborn in our workspace. And then the heat map function in Seaborn takes in a 2D matrix and optionally a color map, and it makes one of these pictures. Okay.
One question. So now we are looking at a new data set that's called digits. And in this digit data set, we actually have like the image, like the data itself resemble the number.
Yeah. That's right. Yeah. So this data set is a data set, like the features of this data set are the pixel intensities of pixels in images of hand-drawn digits. But they could just as well be properties of houses or wines or something like that. Of course, the properties of houses wouldn't make, like it wouldn't make sense to visualize the properties of houses in this way because that's not going to form like a cohesive image. Yes, Allison.
In terms of the coloring, is there like a default or do you always have to set the color? Because it looks like you set it to gray.
Yeah, let's see what happens if I don't include this. There is a default. I think it's called cube helix by default.
Oh, okay.
Yeah, so yeah, but you can like oops. Oh, yeah, you can make it like Dartmouth green or
Oh, that's cool.
ish. Yeah. There we go. I think there's a, is there, oh. There's no Princeton orange. All right. Oh, well. Well, guess Dartmouth is better than Princeton. All right. There we go. Okay. There we go. Okay. So that's one thing you can do. Another super useful library is called Plotly Express. And I've imported it and I called it PX. Plotly P and then X is Express. That's how you usually call it. One useful thing is like scatter plots. This function takes in a data frame, and then you can say like what the X coordinate is and the Y coordinate is, and then it'll make this like interactive scatter plot. So this is for the housing data set, remember? So each dot here is some house, and then the X axis, I've told it to plot the year the house was built, and then the Y axis is going to tell us the sale price. And then, we could dig into each dot and, read out the specific values. You can also make 3D scatter plots, which looks kind of cool. So I'll do that with the wine data set. So to do that, we use the scatter 3D function and pass in a data frame. And then we have to tell the Plotly how to make the plot. So we're going to set the X coordinate to the alcohol, I think, percentage of each wine. So something like the proof. And then Y is going to be the magnesium content. And then Z is going to be the ash content. The color is going to be related to the hue which is there's some scalar value of the different lines. And we're going to map it onto a particular color map that doesn't correspond to the like scale, like we don't know what that scale was, but it's some set of values that can take on, looks like real numbers. And then the size of the dots is going to be the color intensity. And now each coordinate here is a different line, and we can see like all its properties. So on this 3D axis, we're plotting 1, 2, 3, 4, 5 things all at the same time. So that's kind of cool. Yeah, Allison.
2 questions. The first is, so I guess it's the benefit of the 3D plot. It just like it has more dimensions, whereas the 2D is only an X and Y.
Yeah, I mean, it's not that 3D is better than 2D because it can be confusing to look at a 3D thing. So it just another way to show what's going on. So, you know, it's something else that is a tool. And
yeah.
And
then my second question was like, when you're presenting this, like, how do you make it so, I don't know, like if when we're like presenting data, they go to these like notebooks, and so it's in this format, or like, do you copy it into something else, but it's still interactive?
Well, you can. So, I mean, one thing you can do when you're talking about when you're making data stories. Yeah. So you can just literally screencast the notebook and like scroll around in it, or you can also download. So any image in a notebook, you can like download. It's just a website. So you can like save image as. Plotly has this little thing that comes up. You can download the plot as a PNG. It won't be interactive in your like in your like PowerPoint presentation or something like that, because like PowerPoint can't, as far as I know, render web pages interactively. But you know, if you wanted to take a screencast of like scrolling through different values, then that's something you could do. Let's see, I'll just go through a few more examples. Matplotlib is another useful library. Each of these libraries, by the way, is absolutely enormous. So it's not practical to go through like an exhaustive list of everything these libraries can do, but I just want to like do a kind of whirlwind tour. And then on Wednesday, we'll do some more like digging into a different collection of data sets. Here's how you can plot things in Matplotlib. So the plot function is like the default Matplotlib plot thing. Here we're going to plot, we're going to sort all the houses by year built. And because they're sorted, the position along the x-axis is going to give us the like rank of the house's age. So the, you know, earlier the house was built, the earlier, the like higher the rank, or like the closer to 0, I guess, the rank. And then we're going to plot it. This syntax says, so each color is a different character, letter. K means black. And then each line style is a different symbol. The dash, or like the single hyphen, means just a solid line. So K dash means a solid black line. And you just have to look up what the different line styles are there. And then we're going to make the X label say house age rank, and the Y label say year built. And when you run this stuff, it produces this plot. Okay. Yes, Allison.
2 things. The first is, so how do you look up what these different symbols are in terms of line types and color types?
Yeah.
Oh, okay. Sorry, I didn't realize it was that simple.
Yeah. So you just look up the function name, and then it'll, there's like a list somewhere. So it'll say, I think style or something like that. Oh yeah, here we go. Yeah, so here's the line styles. So you can have solid, dashed, dash dot, dotted, or none, which would be like a scatter plot. And then marker color. Let's see.
I saw color
Let's
or
see.
C in that list.
Yeah, so there's a separate thing. You can specify color separately. Oh, line 2D properties. Yeah, I guess it's somewhat annoying to get the get to like the actual documentation. You kind of have to dig around, but here are the different marker shapes. So you can add, like if you wanted a scatter plot, you could have like circles would be the lowercase o. V is like downward pointing arrows. The caret symbol is like upward pointing arrows. You can have left pointing arrows, right pointing arrows. I think 8 is like a, okay, bye Green. It's a probably an octagon. I'm gonna guess S is square maybe, etc. Yes, Allison.
And second question was, how do you add titles to these graphs, or is that not relevant?
Yeah, you can say plot dot title, house pages. Oh yeah. Matplotlib does it in a notebook, does this weird thing where it like prints out. So this function returns something that gets printed to the notebook. So if you include a semicolon, it suppresses that output and it looks a little bit nicer. So like if I don't do this, you can see the thing that this outputs is like a text object turned into a string. So it's a little weird to include that. So if you include the semicolon, it just kind of looks nicer. All right, we are out of time for today. So what I'd like to do on Wednesday is play around with some data sets that, so we'll kind of find a data set that we're interested in. There's a big repository. Let me share it with you. Okay, I'm going to paste it into Slack. Why don't you all take a look at that repository of data sets and see if anything looks interesting to you. And then we can, if anyone has ideas about something that you want to dig into, then we'll like download that data set and we'll make some plots with it and try to like understand what's in the data set, what sorts of ways might we want to visualize it, etc. This repository has, a ton of data sets on a very wide variety of topics. So, and then what you want to do is pick something with the green check mark. The orange ones are like kind of known to be badly formatted. You could find like German political speeches. Yeah, really quite a lot of stuff. That might be a weird one to look at. There's like psychology data sets, sports data sets, time series data sets, all kinds of interesting stuff. GIS is like geography stuff. So if you wanted to make maps, we could dig into that.
Are there any, oh, sorry. Are there any general types of like data that you would say, like just since we're starting out, that's easier to work with than other, or like things like just starting out that may be harder that we may not realize?
I think it's worth just going for it. I don't know that there's like a particular type of data that's super hard. I think it's really what you're all interested in, is what we should play around with. And, we'll figure out how to play around with the data set. If it's a super complicated, if the data set's badly formatted, then it's going to take a while to like clean up the data set. And so most of our time going through a data set might be spent cleaning it up, and then we might not get to like deep insights into that data set. Whereas if it's like some simple CSV file that we can just download, or an Excel spreadsheet we can just download, then we can start like making plots, and then we'll spend most of the time on plotting. So. And then on Friday, we've got the Department of Health folks talking to us. So they'll kind of tell us about their data sets and what they're interested in. All right. See you all on Wednesday, everyone. Sorry for going a bit late, and have a great rest of the day. Take care.